In example 8, we are given that a geometric series has first term 1 and a common ratio r is positive. Here we have to pay attention to this condition of r being positive, because later on we will probably need it to eliminate any inappropriate values of r again. The sum of the first 5 terms is twice the sum of the terms from the 6th to the 15th inclusive. So what does that mean? Well, if you look at the sum of the terms from the 6th to the 15th inclusive, it really mean this 6th term, 7th term, and all the way to the 15th term. When we have the SN formula, we know that we always sum from U1. So we have to make reference to a summation from U1, U2, and all the way to U5, U6, and all the way to U15. Now, this will have a few extra terms, which is the first 5 terms that we have added in, right? So right up to this, which is essentially this, right? So from here, can we see that this is actually sum of the first 15 terms minus the sum of the first 5 terms. So the sum of the terms from the 6th to the 15th term can be represented as S15 minus S5. So we will have this. Let me write it properly. It means this sum of the first 15 terms subtract sum of the first 5 terms. So this is this. Now we need to work with this condition to prove that r power 5 equals to half times root 3 minus 1. Now, knowing the sum of the first 5 terms as a r power n minus 1 over r minus 1, or we can use the alternative a 1 minus r power n over 1 minus r. That means we can have a 1 minus r power n being 5 here over 1 minus r equals to 2 times the sum of the first 15 terms, which is a 1 minus r power 15, n being 15, over 1 minus r, minus sum of the first 5 terms again. So that will be a 1 minus r power 5 over 1 minus r. From here we can see that the whole equation has a common denominator 1 minus r. We can multiply throughout by 1 minus r, giving us only the numerator, the terms in the numerator. And when we simplify, we will obtain the equation 2r power 15 minus 3r power 5 plus 1 equals to 0. To obtain the condition that we need to prove the equation for r power 5, we need to proceed to solve this equation involving r power 15. Now, how can we proceed with this? We observe this equation carefully for relationship among the terms. Do you see any relationship between these two? Well, some of you might be able to see that r power 15 is r power 5 raised to the power of 3 again. So, if we replace r power 5 by x, we will end up with the equation. Let's see, we'll have 2x cubed minus 3x plus 1 equals to 0. So let's proceed. So we will have 2x cubed minus 3x plus 1 equals to 0. How do we solve this cubic equation? Recall our remainder and factor theorem that we can use trial and error. X equals to 1 will reduce the expression on the left hand side to 0. Therefore, x minus 1 is a factor of 2x cubed minus 3x plus 1. Since x minus 1 is a factor, we can use long division or through observation to obtain the second factor, 2x squared plus 2x minus 1 equals to 0. From this, we can see that x equals to 1 or 2x squared plus 2x minus 1 equals to 0. So, knowing that x was r power 5, we have r power 5 equals to 1, or r power 5 being x can also be the roots from this equation, the second equation, and we are proceeding to use quadratic formula to solve it. So it gives us minus b plus minus b squared minus 4ac over 2a. That gives us and this root 12 simplifies to square root of 4 times 3. So root 12 is root 4 times root 3, and that is 2 root 3. Simplifying this further, we will have, we divide numerator and denominator by 2, we'll get minus 1 plus minus root 3 over 2. Now we can see quite easily here that there are two possible values for r power 5. Negative 1 plus root 3 over 2, which is a positive number, or negative 1 minus root 3 over 2, which is a negative number. Since given in a question that r is positive, we know that r power 5 has to be positive, and therefore r power 5 must be equals to negative 1 plus root 3 over 2. And that answers the question. Thank you.